Alright, today we're going to be covering graphs and lines. So the first thing we're going to be dealing with is talking about standard form of a line. So there's different algebraic ways that we can express a line. And the first way that we are going to discuss it will be standard form. So, standard form. And standard form is simply ax plus by equals c, where a, b, and c are typically going to be expressed as whole numbers. So no fractions for those values. And if we were wanting to graph this, so say if we have the standard form 3x minus 2y equals 6, and we want to graph this, the way that I like to do this is that we can deal with both the x and y intercepts, and then we can graph both of those on our graph. So let's first assume when y equals 0, we are going to be solving for the x-intercept. So we would have 3x minus 2 times 0 equals 6, or otherwise known as 3x equals to 6, or x equals to 2. So that will be the x-intercept. So for when x equals 0, that's going to give us the y-intercept. So we'll plug that into our original equation, and we're going to get 3 times 0 minus 2y equals 6, or we're going to get minus 2y equals 6, or y equals to negative 3. Alright, now we can graph this. A little bit. So let's assume that we had our y-axis and we have our x-axis. We know that the y-intercept is minus 3. 1, 2, 3. And we have an x-axis of positive 2. 1, 2. So these are both of our axes, and because we have 2 points on our graph, we can go ahead and draw a straight line through those 2 points, and we have successfully graphed 3x minus 2y equals 6. And that's the way I typically like doing those types of problems, asking the graph a equation that is presented to us in slope or standard form. Alright, some important details to remember. If we have the line, say, y equals 5, that is actually going to be the horizontal line at value y equals 5. So 1, 2, 3, 4, 5. And the line y equals 5 is the horizontal line at where all y values on this line is y equals 5. Similarly, if we had the line x equals negative 2, well, that is just a vertical line where all x values equals negative 2. So 1, 2, and we are going to have a vertical line for every point on this vertical line, the x value equals to negative 2. Alright, so let's go about trying to calculate slope. The slope of a line. Slope. We can get rid of that. Okay, so if we have the slope of the line, we might have 2 different points. So point 1 is x1 comma y1. Point 2 equals x2 comma y2. So when we have 2 points along a line, we know that the slope of the line, we're going to denote slope as the letter m, is simply going to be y2 minus y1 all divided by x2 minus x1. Or sometimes people shorthand say this as the change in y divided by the change in x, where that little triangle shape is the lowercase letter delta. So delta y, delta x, the change in y, the change in x. Or sometimes it is referred to as rise over run. So, for example, if we have 2 different points, say point minus 3, comma, minus 2 as 1 point, and we have another point as 3, comma, 4. We can plug these values into our slope equation. The equation equals to y2 minus 2, all divided by x2 minus x1. So that is the equation of the slope. So 4 minus negative 2 equals to positive 6. 3 minus negative 3 is also positive 6. 6 over 6 equals a slope of 1. So we have talked about standard form as ax plus by equals c. And we also are going to be dealing with what we call slope-intercept form for talking about ways that we can express a line algebraically. So slope-intercept form, which is y equals to mx plus b, where m is going to be the slope of the line and b is what we call the y-intercept value. So if we have a line already written in slope-intercept form, say y equals negative 2/3 x minus 3, and we are asked to graph this using slope. Well, we can, let's first draw a quick y-x-axis. We have a y-intercept here of negative 3, so 1, 2, 3. We have a slope of negative 2/3, so that means we are going, our rise, so-called, is 2 down, and the run is 3 across, so 3 across and 2 down will be representing our slope. So we have plotted another point on our graph, and now we can draw a line through those 2 points, and we have successfully graphed that line that was given to us in slope-intercept form. So we have done standard form, slope-intercept form. One last form for today, we have point slope form. Where a point slope form is written as y minus y1, it's getting a little messy, y1 equals to slope m times x minus x1. So we typically use point slope form when we have the slope of a line and 1 point from on that line. So if we were given for a line, we were told that the slope of the line equals to 1/2. This line also passes through the point negative 4/3, and we may be asked, given that the line has this slope and passes through this point, why don't you write the equation of the line, the standard form of the line that has slope 1/2 and passes through the point negative 4/3 or negative 4/3. So the first thing we gotta do is plug this information into our point slope form equation. So we're gonna have y minus 3 equals to 1/2 times x minus negative 4. So the first thing I would want to do is get rid of that minus negative 4, or deal with that at least. So that y minus 3 equals 1/2 times x plus 4. We can then distribute that 1/2 in. Y minus 3 equals to 1/2 x plus 2. Now remember, we want to get an ax plus by equals c form, so we're going to combine our xy terms on one side and all our numbers on the other side. So we're going to add 3 to both sides and subtract 1/2 x to both sides. So we're going to get minus 1/2 x plus y equals to 5. So we're almost done. So we want to make sure that our a, b, and c value are in whole numbers, and because we got this fraction here, the way that we can get rid of that fraction is we can multiply both sides of the equation by 2. So if we multiply both sides of the equation by 2, we're going to get minus x plus 2y equals 10. And that's how we can rewrite that in standard form. Alright, so let's deal with like a standard word problem that we might get in which we can use lines and graphs. So a small manufacturing company manufactures picnic tables. It has a weekly fixed cost of $1,200 and a variable cost is $45 per table. Find the total weekly cost of producing X number of tables. How many picnic tables can be produced for a weekly total cost of $4,800? So when we say that we have a fixed cost of $1,200, that means this company every single week has to pay $1,200 a week regardless of the number of tables that they make. So maybe their rent per week is $1,200. So regardless if they make 1 picnic table, 2 picnic tables, 1,000 picnic tables, or 0 picnic tables, they gotta pay that $1,200 in rent. And then we see that they cost them $45 per table to produce. So maybe the cost of materials and labor turns out to be $45 per table to make. So our total weekly cost, TC, still going to represent total cost, is going to equal to the fixed cost per week plus what we say the variable cost, that would be the $45, times the number of units that they produce. So total costs in this case will equal to 1,200 plus $45 times the number of tables that they produce. So we have written the total cost producing at production in terms of how many picnic tables that we make. So if we know the total cost, now we can answer the second part. If we know that the total cost is going to be $4,800, how many picnic tables give us a total cost of $4,800? So we can plug in 4,800 into this equation equals 1,200 plus 45x. If we subtract 1,200 from both sides, we'll get 3,600 equals 45x. If we divide 3,600 by 45, we are going to get 80 equals x. So 80 picnic tables gives us a total cost of $4,800. All right. Moving on to another word type problem. A plant can manufacture 50 tennis rackets for a total daily cost of $3,855 and 60 tennis rackets per day for a total daily cost of $4,245. So we are given 2 production points where we produce 50 rackets with a total cost of $3,855 or 60 rackets for $4,245. So the first question is assuming that the daily cost productions are linear related, find the total cost of producing that number of X rackets. So this is an example where we have 2 points on our line and we need to figure out the equation of the line that passes through those 2 points. So if we were to, instead of saying X and Y, we're going to have rackets on a horizontal axis, and then we're going to have the total daily cost as our vertical axis. So we have 2 points, 50 comma 3,000. I'm going to leave out that part. 3,855, and we also have 60 and $4,245. So those are our 2 points. And now remember, the equation of slope is y2 minus y1 divided by x2 minus x1. So we're going to have our slope equals to 4245 minus 3855 all divided by 60 minus 50. So if we plug into the calculator, what is 4200 or 4245 minus 3855? Well, 390 divided by 60 minus 50 divided by 10, and we are going to get a slope of $39. So we have the slope, and we also have 2 points here. We have point 1, point 2. We can then use point slope form to be able to come up with an equation of the line. So let's use this first point. We have 2 points. We can choose one of them to incorporate into point slope form. So we have, let's move this over a little bit. So we're going to have y minus our y value equals to our slope times x minus our x value. We can distribute that 39, so we're going to go y minus 3855 equals 39x minus 39 times 50 is 1950. We can write this as slope-intercept form by adding 3855 to both sides, and we're going to get y equals to 39x plus 1905. Okay, so that answers the first question. We have expressed the cost function, so total cost equals to 39x plus 1905. Alright, so part B is simply graph the total cost function. So if we wanted to graph the total cost function, we are going to have a y-intercept of, say, 1905. So if we were each grid mark was considered 1,000 units, so just under 1,000 units, we're going to have 1905, and we're going to have a slope of 39 units. So why don't we just draw a upward sloping line such as this to represent that we are graphing the total cost function. So total cost as a function of the number of rackets that they produce. Okay. Part C, interpret the slope and y-intercept of this cost function. So remember, we have a total cost equals to 1905 plus 39x, where x represents the total number of rackets. So the y-intercept of this equation is telling us the b value, or let's do lowercase b, or $1905 is the total cost when 0 rackets are made. Or another way to say this is the 1905 is the fixed cost. That's how much it's going to cost this company on a daily basis to produce rackets if it produced 0 rackets. Or that's just what we call the fixed cost. And then the slope in this case, or the $39, is going to be the change in total cost of producing one more racket. Or another way of saying this as $39 is the variable cost. Alright, that does it for today.